I sometimes think, some of you know Carnap had this idea of logical probability. Other people, my own dissertation director, Jacques Hintica, he also had this idea for a while in a more sophisticated form. He wasn't so went into it philosophically, and this kind of program kind of fell out of interest. But, something like for the right language to describe the world, there's a right probability distribution over the descriptions in that language. So there's an idea, Carnap had this idea. He thought it's based in logic. This is like that, only based in physics. And so not accessible to us in the way logic might be thought to be accessible to us. Incidentally, this idea has been revived somewhat in people like Tim Williamson and Roger White. They think that there's an objective probability distribution. Incidentally, they don't know what it is. They have sort of transcendentalish kind of arguments that there is such a probability distribution. And I've told a few of the people like this, I can give it to you, because it comes from physics. And they don't like that so much, but I think there's something to be followed up there. Here's an important point. I'm now going to tell you how it is that this mentaculus, this theory of the world, grounds the past, present, future distinction. But you might think it already introduced it. Didn't I say there's a past hypothesis that the world at the beginning has a very low entropy? I did say that, but that was just to communicate. It actually does not make the past-future distinction. I'm not using it in characterizing it. All that's being said is that the universe has a boundary condition. A boundary condition. It really doesn't have to be called the past. The idea is that if you can show now that it's very likely that a world that evolves from that very kind of special low entropy condition will be one like ours, in which has our kind of temporal arrows in it, all pointing in the same direction, as say, away from that initial condition, then you will have explained why it's right to call that boundary condition the past. That's my claim. Because someone who's more metaphysical about time might not like that. They may think, look, time is just fundamental. It comes with its own arrows. It comes with flowing from that thing. And they wouldn't think that I did enough to do it. Okay. All right. So this is an argument we could get into. In fact, this argument took place last night. Why should anybody believe this preposterous hypothesis that I'm suggesting, that the right theory of everything of the universe will contain basically the metaculus in it? Here are some reasons. Well, there are reasons to believe the dynamical laws, but nobody quite knows what they are. But because we need to get rid of these aberrant trajectories on any theory, quantum mechanics or classical mechanics or string theories, and really developed in a way that you can ask these kinds of questions in a clear way. But on any of them, they will be aberrant states. You've got to get rid of them. This probability distribution gets rid of them. Probabilistically, it's true, so they're still possible. They're just immensely unlikely to be zero. So you're going to need something like this for any of the kinds of theories that people have thought up. And of course, the metaculus does ground the second law and the other thermodynamical laws and more fine-grained statements of thermodynamical laws, such as the mechanical laws. And so this is good reason to believe it. It may not be the only way of getting them. So the question is, look at other ways and compare them and see which we have better reason to hold. So because of, related to the first point, the mentaculus really does successfully underlie applications of the dynamical laws. Halley, when he predicted the return of his comet, named for him, was really presupposing that the comet's microstate, he had no access to it, he just saw that it was he didn't even know didn't know that comets were made out of ice. But its macrostate, whatever it was, he was presupposing it wasn't its microstate that was compatible. That wasn't one of these aberrant ones. So he was like Moliere's famous guy who discovered he was speaking prose all his life. I don't know if you know the Moliere play. But he was using the metaculus. If I got into a time machine, I would go back and say, hey, you were using the metaculus, and probably throw me out of his the Royal Society. I also think that calculus builds correct probabilities in other cases, like in gambling cases. We make up gambling devices in situations where there are very important symmetries so that we can't predict the outcomes. Now, of course, if microdeterminism is true, then given the state of the universe at the time that you throw the dice, the outcome is predicted. This is the inevitability. Given the state of the universe, micro state of the universe, or even a backwards light cone, given what we think about our universe, or even smaller parts, it was inevitable we would end up in this room. Don't fight it. But given the macro state, the probability is probably rather small that we don't end up in this room. So if you think of these probabilities as conditional probabilities like we should, you can see that there's an important difference there. Okay, I have a particular view about how to think about laws and probabilities that derives from David Lewis's best system idea. Heather will attack it later, but when I was reading Mach, I realized Mach had a form of this idea. Only he applied it, he thought that the laws were just sort of compendiums or summaries of the observations. That I think isn't right. Lewis thinks of laws as being sort of the right summaries, simple summaries, or summaries that satisfy certain conditions of all of the fundamental facts. I think that's a really interesting idea. And I'm not going to argue for that here because I'm already going to know for a long time. Okay. So I think there's good reasons to believe in the calculus. There are big questions that come up about it, deeper philosophical questions. There are some, namely what are laws? Well, I told you a little bit about what I think. What are probabilities? And you know, I'm writing a book about all of this stuff. The book will be about 4 trillion pages long, even longer than my book. It'll be finished as Mach laws have done that. Okay, I now want to say a few words to make it plausible that the calculus really will play this interesting role in decrying 4 things. And what I mentioned, I think it can decry, play this role in explaining how thermodynamics fits into the micro world, how the lack of aberrant, the non-existence of aberrant trajectories fits into the macro world. We talked about it a little bit. Those are the hard problems of physics. But also the hard problems in physicalism, how the existence, the epistemological temporal asymmetry fits into the macro world, and how the asymmetry of influence fits into the macro world, and how the myth of free will, the illusion of free will fits into the macro world. Okay, so I'm going to do all that pretty quickly in discussion. Okay, here's the point. If you start taking this probability distribution really seriously, but you will apply it as Boltzmann did at a time now, you realize right away that it has these crazy predictions about the past. Namely that entropy was bigger in the past. Because everything is symmetrical in these classical mechanical laws. And that means that if you were to use this probability distribution to make predictions about the past, you would predict that those books, I was just in the British Museum, God, travel was amazing, Saturday. That was like 2 days ago. In the British Museum are some copies, the first copies of Newton's Principia and Haley's books and those things like that. Most of them I think are in the Royal Society. But these books are, if you give this probability distribution and you were to take the macro state of the world, what I was seeing in the museum, and a lot of other things that go on that day, it would be more likely, given this probability distribution, not only that entropy will increase to the future, those books will decay eventually, and so on, but more likely that they were not accurate recordings of anything in the past, but that their history, so to speak, was the exact symmetry, the exact mirror image of their decay. Because of this symmetry of the fundamental laws. But that's absurd. And in fact, you can see that would lead to an epistemological crisis, right? Because none of the evidence we have for the Newtonian laws would really be evidence. This is a whole other paper, and I'm interested to think about it. So this can't be right. It's self-undermining.